Yeah. So here dimension model is the most important topic. Why it is important? Because it captures the changes of the data, right? I already explained. A type of data modeling suited for data warehousing. In a dimension model, there are two types of tables: dimension tables and fact tables. So dimension table records information. Dimension table records information on each dimension, and fact table records all the fact or measures. Fact nothing but metrics, measures, calculation related part, right? What is data modeling? There are three levels of data modeling. Data modeling nothing but here they are conceptual, logical, and physical. This section will explain the difference among the three, the order with which each one is created, and how to go from one level to the other. Conceptual data model. Features of conceptual data model includes the important entitles and the relationship among them. No attribute is specified at this level. The data modeler attempts to identify the highest level relationships among the different entitles. So that is called concept. Just concept, and that's it. Logical model. Here logic it will be implements like features of logical data model includes all entitlements and relationships among them. All attributes for each entity are specified. The primary key for each entity is specified. Foreign keys identifying the relationship between different entities are specified. Normalization occurs at this level. At this level, the data modeler attempts to describe the data in as much detail as possible without regard to how they will physically implemented in the database. In data warehouse, it is common for the conceptual data model and logical data model to be combined into a single step. Okay, that is deliverable. The steps for designing the logical data model are follows: like identify all entities, specify primary keys for all entities, find the relationship between different entities, find all attributes for each entity, resolve many-to-many relationships. That's normalization. Physical data model. Specification all tables and columns. Foreign keys are used to identify relationship between tables. Denormalization may occur based on user requirements. Physical consideration may cause the physical data model to the quite difference from the logical data model. At this level, the data modeler will specify how the logic data model will be realized in the database schema. The steps for physical data model design as follows: convert entities into tables, convert relationships into foreign keys, convert attributes into columns. Okay, in this way, just go through this document like this. And the most important is like dimensions. That what are the dimensions? SCDs nothing but slowly changing dimension. What it is, how to capture. Most important three types. First one is slowly changing dimension. In type 1, slowly changing dimension, the new information simply overwrites the original information. In other words, no history is kept. For suppose we have a source table and we have a target table. We loaded source data to target data by implementing some. I already explained about. One second. I already explained about the ETL process. So source to target mapping. So here in technically we call STM also, source to target mapping. So here loading source data to target table. First day we loaded. Second day again we are loading source to target. What happened? No, the data. What are the data is there? No, the previous data already present in target data will be overwrites by the recent data. Okay, no history will be tracked for that previous data. Completely it will erase the data and insert the new data as new data. Okay, that is called SCD. So every day it will the table will be truncate and load. Right, truncate means delete and load. table will be there, the table data will be removed. That is called truncate. I already explained in SQL basics, right? For suppose in our example, recall we originally have the following table: customer key name state, this one 101, Christina, that's some example. After Christina moved from Illinois to California, the new information replaced the new record, and we have the following table: customer key names. For suppose one customer is there, for suppose one job holder is there, for suppose in India, for example in India, you joined TCS in HYD location. Later you moved to Pune location. What will happen? Actually, the employee's history will also be there, but if you implement SCD type 1, you will it will maintain only one record, that is from Pune record, the most recent record it will maintain. The history data will not be maintained by the system. Like that, if we design so SCD type 1, it will maintain the recent data only, not historical data. It will not maintain. Okay. Advantages. What is the advantage of this? Like, this is the easiest way to handle the slowly changing dimension problem, since there is no data to keep track of the old information. So no need to worry about historical data. Simply it was implemented with SCD type 1, and the table was implemented by table was loaded by SCD type 1 method, so we can't get any historical data. So easily we can get that recent information like that. What is the disadvantage? Like, all history is lost. History will be lost if you want to backtrack the employees job related data. We can't backtrack by applying the methodology. Okay, it is not possible to track back in history. For example, in the case the company would not be able to know that Christian is lived in. So first suppose he is not from Hyderabad, lived in Hyderabad, like that. So mostly this will use actually in simple mappings 50% of the time. Okay, actually when to use. Okay, type 1 when to use. Slowly changing dimension should be used when it is necessary for the data warehouse to keep track of historical changes. Okay, not necessary. If history is no need to maintain, like current transactions, so no need to maintain the historical data at that time. If we can use SC type 1, if no need to maintain historical data, you can use type 1. Let's see the type 2. Type 2 in detail, don't worry, it is very important topic. The entire ETL jobs, now almost 60 to 70% ETL jobs are in SCD type 2 only. So I will explain in detail with practical examples. Okay, just this is theory, just theory only. In type 2 slowly changing dimension, a record is added to the table to represent the new information. Therefore, both the original and new record will be present. The newer record gets its own primary key. In our example, for suppose one person is there. Recall originally we have the following table like customer key name state. Right? For suppose one person is there. For suppose for one person Jagdish is there, moved from Hyderabad to Pune. We add the new information as a new row into the table. So now it contains Hyderabad record and Pune record. Right? Both records it will contains. Okay. No need to worry about that. I will explain in detail while we are going further. The advantages is this allows us to accurately keep on historical information. Disadvantages like this will cause the size of the table. Okay, every day it will maintaining the history also. No, that's why the table size will be increased. Right? In case where the number of rows for the table is very high to start with, the storage and performance can become a concern. Okay, if the data is huge, the performance issue also may occur. Right? Then this necessarily complicates the ETL process. this necessarily complicates the ETL process usage about 50% of the time. Yeah, okay. When to use slowly changing dimension should be used when it is necessary for the data warehouse to track historical changes. Okay, yeah. So slowly changing dimension in type 3, there will be two columns to indicate that particular attribute of interest, one indicating the original value, the one indicating the current value. There will also be a column that indicates when the current value becomes active. In your example, for suppose a person in from Hyderabad, so to recommended type 3 slowly changing dimension, we will now have the following columns: customer key, for suppose customer key name, original state, current state, and effective date. For suppose the person moved from Hyderabad to Pune, the original customer key name, original state, current, and the value. So this does not increase the size of the table since new information is updated. This allows us to keep some part of history. Disadvantages: the type 3 will not be able to keep all history. So the most recent data, for suppose he moved from Hyderabad to Pune to it will maintain Hyderabad record and Pune record, and Pune to Mumbai he moved. So what will happen? Pune and Mumbai record only maintain, that Hyderabad record will be deleted. So, right? That is the type 3 SCD, right? When will we use? Type 3 is rarely used in actual practice. When to use, like type 3 dimension should only be used when it is necessary for the data warehouse to track historical changes, and when such changes will only occur for a finite number of time. For if you want to track back few instances only, so at that time you can use type 3. So in this table will explain in detail. Okay, visual representation I created, okay, by using napkin AA. Visual representation I created, just you can go through this. Yeah, no worries. What is staging area? Why we need it in a data warehouse? Staging area is nothing but a temporary storage. So it always truncate and load from the staging area to target table. It will load the data. Actually, source to staging to target, the process will be like that. Okay. Storage always will be truncate and load. So source to staging, it will load the records. So once staging was loaded to target, staging will be truncate and load, and again it will receives the data from source, it load the data to target, and the data will be truncate and load once the target was loaded. Like that, the staging, that is the difference of definition of staging. Actually, if target and source database are different and target table volume is high, it contains some millions of records in the scenario. Without staging table, we need to design your Informatica using Lookup to find out whether the record exists or not in the target table. Since the target has huge volume, so it's costly to create cache. It will hit the performance. Performance approach will give you good performance. Okay, it will avoid full table scan to determine insert, update, or target. And also we can create index on staging table. Since these tables were designed for a specific application, it will not impact to any other schemas users. While processing flat files to data warehousing, we can perform data cleansing, and also known as data scrubbing. Is the process of ensuring that a set of data is correct and accurate. During data cleansing, records are checked for accuracy and consistency. Since it is one-to-one mapping from ODS to staging. ODS nothing but operational data source. To staging, we do not truncate and reload. We can create indexes in the staging state to perform our source call for tests. If we have the staging, no need to rely on Informatica's transformation to know whether the record exists or not. So mostly staging table will use in lookups to search the particular values present in the already present in the target or not, right? Data cleansing, nothing but data merging, data scrubbing, ODS, data structure sources. So go through this document. Okay, what is surrogate key? One of the important question. Surrogate key is a substitution for the natural primary key. It is a unique key identifier or number. Is a substitution for the natural primary key. Primary key we will cover this in SQL basics. Okay, normally created by a database sequence generator for each record for a dimension table that can be used for the primary key to the table. As surrogate key is useful because natural keys may change. Okay, what is the difference between a primary key and a surrogate key? One of the important questions they will ask. A primary key is specially constrained on a column or set of columns. A primary key constraint ensures that the columns so designated have no null values. Primary key should not be a null values, does not allow null values, and that every value is unique, no duplicates. Physically, a primary key is implemented by the database system using a unique ID index, and all the columns in the primary key must have been declared not null. A table may have only one primary key, but it may composite key consists of more than one column. A surrogate key is column or set of columns that can be declared as the primary key instead of a real or natural key. Sometimes there can be several natural keys that could be declared as the primary key, and these are all called candidate keys. So a surrogate is a candidate key. A table could actually have more than one surrogate key, although this should be unusual. The most common type of surrogate key is an incrementing integer, such as an auto increment column in MySQL, or sequence in Oracle, or an identity column in SQL Server. Okay, the difference between primary key and surrogate key is nothing but it is a column or set of columns, right? Once go through this document, it will be helpful. Okay, after this the data warehouse concepts we covered lightly. Just if you want in depth, you can go through the document. Okay, let's move into that actual course, that is Informatica. Let's start in the next session. Okay, bye.